Hey everyone, welcome back to the channel. Today we are going to talk about something that once I got my head around it, really changed the way I thought about it. Hash tables. If you have ever worked with large amount of data and wanted lightning fast access, hash tables are the best way. But I'll be honest with you, when I first encountered them, I was a bit confused. So today we are going to walk you through what hash tables are and how they work and share some personal experience of when they saved my code and when they didn't. Let's start with something basic. Imagine you have a list of data, maybe a list of names or number, and you want to look up a specific one. With a regular array or list, you would have to search through the whole thing, potentially checking every item. This could take a while, especially if the list is long. Now imagine a magical system where you could simply jump directly to the item you're looking for almost instantly. That's essentially what a hash table does. It maps data to a specific bucket where it can be found right away, no scanning through the whole list. When I first started working with hash tables, I didn't fully appreciate how powerful they could be. I was working on this small project that involved processing customer data. At first, I thought it was just a few address, names, and order histories. I thought, why not just throw everything into a list? Easy enough, right? But as the data grew, I quickly noticed something. My program was starting to slow down when I needed to look up information, and that's when I realized I needed something faster. Enters hash table. The core idea behind them is really simple. You take a key, something like a person's name, and run it through a function called a hash function. This function takes the key and turn it into a number which corresponds to a specific index in an array. It's like turning a name into an address, so you know exactly where to find it. Here's where things get interesting. This number is the location in the array where the data is stored. So when you need to look up that person's information again, you don't have to scan the whole array. You just hash the key and jump directly to the right spot. Here's something I have learned the hard way. Hash tables are not perfect. One of the challenges that you'll run into is something called a collision. This happens when two different keys, let's say John and Jay, get hashed to the same index. It's like two people showing up at the same address with the same key and you have to figure out which belongs where. I remember this happening with me on the same project. I was so excited about how fast things was running. And then I noticed in some cases my program would slow down again. That's when I realized I was running into collisions. I had to implement something called separate chaining to handle them. Essentially, it's a way to store multiple items in the same bucket without losing data. In separate chaining, when two keys get hashed in the same index, you store them both usually in a linked list or in another structure. So they coexist in the same space. It's not as fast as, but there is no collision. But it's a good way to keep things organized. Now there's another method to handle collision called open addressing. Instead of chaining multiple items in the same bucket, you'll find the next available empty spot in the array. It's like if two people showed up to the same apartment but one just moved to the next room down the hall. That's why this matters. Well, in real world scenarios, especially when working with large data set, the efficiency of your program can really take a hit if you don't handle collisions properly. That's something I had learned firsthand. Once I started using separate chaining, I saw a big improvement. And I was back to the speedy lookups I was hoping for. To sum it up, here's what hash tables so powerful. They give you fast, constant time accessing to data. In the best case, O1 time to complexity, collision are a real challenge, but they can be managed with techniques like separate chaining or open addressing. The efficiency of hash table relies on a good hash function, which evenly distributes keys across the array to avoid too much collision. And once you get the hang of how they work, they are pretty fun to use. Seriously, I saw how quickly I could look up data with a hash table. It was like discovering a superpower. Here's the hash table. Here's the thing, hash tables are everywhere in computer science. You have probably used them without even knowing it. Most computer languages have built-in hash tables. In Python, for example, they are called dictionaries. In Java, they are called hash maps. No matter the name, they all work in pretty much the same way. If you're just starting out and hash table seems confusing, don't worry, I have been there. But the more you work with them, the clearer they become. And trust me, the first time you use a hash table to optimize your code, it's pretty great feeling. Alright, that's all for today's video. I hope this helped you clear up the mystery of hash table. If you have questions or if there's any topic you'd like me to dive deeper into, let me know in the comments. And as always, don't forget to like, subscribe and hit that notification bell so you don't miss any future videos. Thanks for watching and I'll see you in the next video.